Quantum logic is usually presented as a non-classical departure, a weird anomaly forced on us by quantum mechanics. But a new paper flips this explanation order. It argues that in a finite, fully computable setting, classical logic is actually the quotient of contextual quantum logic. The core object is the free orthomodular lattice on two generators, F2. This lattice has exactly 96 elements. By the commutator decomposition theorem, it splits into a direct product of the 6-element modular ortholattice MO2, known as the Chinese lantern, and the 16-element Boolean algebra 2-4. This yields a context, bit vector calculus. Every element is a pair CB, where C is a context from MO2 and B is a 4-bit Boolean vector. Lattice operations act component-wise. The context factor carries the non-distributive structure. Meet and join act as contextual restriction and combination. For instance, the join of elements from distinct atomic contexts forces an ascent to the central superposition layer at context 1. The structure stratifies into 6 layers. 2 layers are central, the Boolean kernel at context 0 and the superposition layer at context 1. The remaining 4 layers are non-central. Commutativity is rigidly determined by the context factor. An element is central if, and only if its context is 0 or 1. The layer dualities are exactly the orthocomplementation of the MO2 factor, a rigidity proven by the structure of the free lattice. The paper also analyzes the quantum material conditionals. The Sasaki, contrapositive Sasaki, and relevance conditionals differ only on the non-commutative part, defined by the commutator. In the context calculus, the Sasaki conditional takes the context of the antecedent, while the contrapositive takes the context of the consequent, showing that logical order intrinsically shifts context. The main result isolates the context-forgetting projection, pi-forget, mapping CB to B. This is a surjective homomorphism of orthocomplemented lattices. The kernel congruence identifies elements sharing the same bit vector. The quotient F2 is isomorphic to the classical Boolean algebra 2-4. Classical logic emerges as a uniform 6-to-1, information-losing image of the contextual calculus. Every Boolean operation is the shadow of 6 distinct contextual propositions. The failure of distributivity is not a defect, it's a diagnostic for intercontext structure. Classical logic is the result of projecting away the context. When you force a context-dependent process into a context-free record, you discard the frame that generated the answer. This reframes the classical regime not as a foundation, but as a limit of information loss.